It's time to start. So today we are going to talk about factoring a polynomial. So if you check your edX, then you will find like we have like tons of problems like factoring some kind of polynomial, maybe factoring a polynomial by grouping, or factoring polynomial by some kind of formulas, or factoring polynomials of the sum or difference of cubes or squares, or anyway, you will have tons of different kind of questions about factoring a polynomial. And this time we are going to focus on like a pretty general case. So let's see if nobody show up. I'm going to start the first example. Let's wait for like 2 more minutes, and if nobody show up, then I will just go on. Okay, so let's start. In general, factoring a polynomial, we can do it we can separate a question of factoring a polynomial into 3 parts. So when anybody? Yes? Okay. Okay, so let's start anyway. To factoring a polynomial, basically, in general, we have 3 steps. So we have like step 1, which is greatest common factor. And step 2, depend on how many terms or what kind of polynomial you have. So depend on the number of terms. We have 3 cases. Two terms, 3 terms, 4 terms. And then we have step 3, which is check. I will show this by example, how this step 1, 2, 3 should actually work. So the first step is find the greatest common factor. So to find the greatest common factor, let me write the full name. greatest common factor. So to find the greatest common factor, what we really need to do is check the factors for terms one by one. And then step 2, after you fact the greatest common factor, step 2 tell you have to check how many terms you have in this polynomial. In this course, mainly you will have like either 2 terms or 3 terms, maybe 4 terms. And there might be some other cases, but in general, it's always satisfy one of these 3 kind of problem. Otherwise, it's not really like our general strategy don't really apply it, or you need some trick. Next is after you apply the corresponding method in step 2, fact is a 2 terms or 3 terms or 4 terms polynomial. So step 3 is check your answer. Here, what I mean by check is you have to check the new factors, those small polynomials, whether you can factor them again. So that's what I want to talk about, and that's a general strategy. So now let's see how this strategy works. By example, oops. Let me make it smaller. Ooh. Oh, too small. Okay, this size work. Now let's start. Here we go. So first, let's see our example like this. Let's start with example here. We have 3x cubed times y plus 6x squared times y. Just bad, please. Minus 3xy and then minus 6y. We ask you to factor this polynomial, thus write this polynomial as a product of several smaller polynomials. So let's see how this works. Actually, question like this is almost the hardest problem you can ever have in this course, like for factoring a polynomial. So let's see how our strategy works. So first step, we need to check the greatest common factor. To check the greatest common factor, we just see what's a factor for each term. So let's, before we write it equals to anything, let's just check these terms one by one. So the first one, we have this is 3x times 3 times x cubed times y, which is equals to, this is 3 times x cubed times y. We have the number part, first variable to some certain degree, the second variable to degree, which is 1 here, and the second one is 6 times x squared times y, also 3 part. Number part is 6, but 6 is can be written as 2 times 3. And then x squared times y, this one. which is 3 times x times y, also 3 part. Number part is 3. First variable x, second variable y, and last one is 6y, so it's only got 2 part, which is 6, the number part, times y, the variable part. But also, again, 6 can be written as 2 times 3. So now for each terms, we check all these factors. We factor the number part and list all the variable part. Now, what is the greatest common factor? The greatest common factor came from, first, let's check the number part. The first number part contains a 3. The second number part contains 3. Here we have a 3. Also have a 3. So 3 is a common factor because 3 exists in every number part. And the next, what's the next factor? The next factor is 2. But 2 is not a common factor because in the first one, here we have no 2. So we only have the factor 2 here in the second term and also in the fourth term. It's not in the first and the third. So 2 is not a common factor, which means the number part for greatest common factor is only 3. We only have 3, 2, these 2 different factors, and 2 only exist in the second and the fourth, so it's not a common factor. 3 exists in the first, second, third, and the fourth. We mark it by the small triangle under it, so that's a common factor. Next, let's check the variable part. The first variable we have is, let's use star, x. But, here we have no x. This means x is also not a common factor because though in the first one, in the second one, and in the third one, we have the x with a small star underneath, but in the fourth one, in the last term, there is no x. So x is not a common factor. A common factor must be a common part in each term. So x is not a part of the GCF, not in the part of the greatest common factor. Let's go on see the next. Next one we have the y. What symbol should I use? Let me use a small tube. We have y, we have y, we have y. So now we see in all these 4 terms, it all contains y as a factor. So in the greatest common factor, we have a y. And more, let's see what should be the degree of y. So in the first one here, we have the y is degree 1. Here, the second one, we have y is degree 1. This one, the third, we have y is degree 1. And last one, we have y is degree 1. So now let's consider what is a common part. In this case, it's because all these factors of y are degree 1. So in the largest possible power you can find for y as a common part is just 1.